Welcome to The Explainer. Today, we're unpacking an absolutely critical, behind-the-scenes framework that shapes the very food products you buy every single day. We'll be looking specifically at the SASB standards, that's the Sustainability Accounting Standards Board, and how they guide the processed food industry's approach to packaging lifecycle management. So if you've ever wondered how massive food corporations systematically track and ideally mitigate their environmental footprint, well, you are definitely in the right place. Let's kick things off with a pretty crucial question. How exactly do companies systematically measure the environmental and regulatory impact of something as simple as a wrapper? I mean, it's really easy to look at a bag of chips or a frozen food box and just see trash. But for the processed foods industry, that packaging represents a massive business cost, a super complex environmental footprint, and honestly, a growing regulatory risk. So how do they measure and manage the whole thing? Here's our roadmap for today. 1. The food packaging dilemma. 2. Measuring the total weight. 3. Sourcing, recycled and renewable. 4. End of life and the 3 Rs. And 5. Strategies for sustainable design. Let's dive right in. Section 1. The food packaging dilemma. Balancing safety and sustainability. We're starting with the core paradox of processed foods. You see, packaging is absolutely essential for food safety, hygiene, and extending shelf life. You literally can't do without it. Yet, it simultaneously creates this massive environmental burden. Every single stage of a package's life cycle, from design to transport to disposal, presents unique environmental challenges and some really strict legislative hurdles. Now, what's really fascinating here is how SASB metric FBPF 410A takes this giant dilemma and just breaks it down into concrete, trackable requirements. If you look at the categories, the standard requires companies to quantify 3 main things. First, the total weight of packaging. Second, the percentage made from recycled or renewable materials. And third, the percentage that is recyclable, reusable, or compostable. It's essentially about turning a really abstract environmental concept into hard, auditable financial metrics. Moving to Section 2. Measuring the total weight, the baseline metric. This is step 1 in managing a package's life cycle. Because look, before a company can even think about improving its sustainability, it has to establish the sheer physical volume of material it's actually putting out into the world. So, the crucial point here, total packaging weight has to be reported on the balance sheet in metric tons. By anchoring this in a standard unit of weight, investors and regulators can actually track a company's progress over time as they try to lightweight their materials and bring down that overall usage. But hey, not all packaging is measured equally in this specific metric. This measurement strictly targets primary packaging, which is the stuff designed to come into direct contact with your food, and secondary packaging, which holds those primary packages together. But notice what's explicitly excluded: tertiary packaging. That means those massive shrink-wrapped pallets used for shipping, not counted here. For this specific SASB metric, the focus is squarely on the packaging that actually reaches the consumer. Section 3. Sourcing, recycled and renewable materials. Okay, so once we know the weight, we have to look at where all these materials actually come from. Companies are facing massive pressure right now to use recycled or renewable inputs to dodge raw material scarcity and consumer backlash, but the definitions here are rigorously policed. And this brilliantly illustrates the really strict regulatory distinction made when calculating authentic recycled content, which is governed by ISO 14021. You've got pre-consumer material, which is diverted from the waste stream during the manufacturing process, though actually that specifically excludes regular scrap that can just be tossed back into the same process. And then you have post-consumer material, the stuff generated by households or commercial facilities. A company literally has to track the exact mass of both to report its true recycled content. Furthermore, what does it actually mean to call a package renewable? Well, according to the Global Protocol on Packaging Sustainability, it has to be composed of biomass from a living source. We're talking trees, crops, even algae. But here's the kicker. The most important part is the math. That living source must naturally replenish faster than, or at least at the exact same rate as, the company depletes it. If you're cutting it down faster than it grows, no way, it is not renewable. Section 4, End of Life. The 3 Rs of regulatory compliance. We've reached the climax of our packages journey and honestly, a massive regulatory pain point for the industry. What happens when the consumer throws the wrapper away? This is where companies face serious compliance risks if they make false environmental claims. First up is recyclable. According to super strict ISO standards, a package is only considered recyclable if it can actually be diverted from the waste stream through available, real-world processes. It's not enough that a material is theoretically recyclable in a shiny laboratory somewhere. It must be able to be collected, processed, and returned to use as raw materials or products out in the real world. Now, reusable is an even stricter term. A package is only reusable if it is literally conceived and designed to accomplish a specific number of trips for the exact same purpose it was created for. And crucially, a company cannot make this claim unless there's an actual dedicated program in place for collecting and reusing it. You absolutely cannot just call a glass jar reusable because a consumer might decide to keep their pens in it. It doesn't work that way.
Finally, we have compostable. Under standards like ASTM D6400, these materials have to meet incredibly strict chemical criteria. They have to biologically break down at a rate consistent with other known compostable materials, yielding CO2, water, and biomass. And most importantly, it must leave absolutely zero visible or toxic residue behind. If it leaves behind microplastics, it completely fails the test.
Section 5. Strategies for Sustainable Design and Mitigating Risk. Let's shift gears here. We're moving from simply measuring these impacts to exploring how companies proactively design their way completely out of regulatory risks. To navigate this crazy, complex landscape, companies align their strategies right alongside these international standards. They're using ISO 1862 to minimize weight, ISO 1864 for recycling criteria, and ISO 1401 to ensure any environmental claims printed on their labels are legally bulletproof. Basically, it's all about standardizing their approach to dodge those nasty greenwashing lawsuits and regulatory fines entirely. To tie this whole shebang together, companies rely on comprehensive life cycle assessments, or LCAs. By mapping out the environmental efficiency of their packaging across its entire lifespan, they uncover some really massive cost-saving opportunities. For instance, developing a lightweight material doesn't just reduce your total metric tons of packaging, it simultaneously slashes overall transportation and fuel costs. Good sustainable design isn't just about reducing a footprint. Ultimately, it's just highly efficient, highly profitable business management. Which leaves us with a final, really critical thought regarding the future of the processed food industry. As regulatory scrutiny gets tighter and tighter, every manufacturer out there must ask themselves, will your packaging outlive your product sitting in a landfill, or is it specifically designed to fuel the very next life cycle? That's definitely something to chew on. Thanks so much for joining me for this explainer. Keep asking those tough questions, and I will see you next time.